Great. So, hey, everyone, thank you for joining us. The reason that we wanted to have this webinar in particular was that New England is currently in the midst of seeing a really unprecedented spike in the cost of natural gas, and that's being driven by global supply chain factors that are very much out of control of energy consumers and policymakers here in New Hampshire. But it does prompt us to ask the question of what does it mean that both our electricity system and increasingly as a heating fuel, we are becoming increasingly reliant on that particular fuel. And are there other options that we could be looking towards as a way to not only save cost, but also reduce emissions here in the Granite State and in New England writ large? And we've got a couple of panelists who have some thoughts about all of this and who have taken time out of their busy schedules to join us and share those thoughts with us. We're going to hear from Joe Short, who's the Vice President of the Northern Forest Center. We're going to hear from Mark Froling, or perhaps Jim Van Valkenburg, actually from Froling Energy, that sells a lot of the solutions that are available. We're also going to hear from William Clark, who's with Liberty Utilities, that is our largest natural gas distribution utility and has some really interesting plans that are starting to take shape in regards to how to think about the natural gas system and what is actually filling those pipes in the years to come. So just so you know, this is in a webinar format, and so you'll have the opportunity to ask questions. Probably the best way to do so would be either to type your question into the Q&A box down below or into the chat window. I'll try to monitor both of them, but if I don't catch a question, my apologies. But you can also raise your hand, hit the raise hand button, and I should be able to unmute you if you'd like to ask your question live. So we're going to let the presenters have a couple minutes to talk about their initiatives, and then we will have the opportunity to pepper them with questions and satisfy all our curiosity once they've finished. So again, thanks so much for being here. And now I'm going to hand it off to Joe Short.
Thanks, Sam. And hi, everybody. While I get my presentation up here, I will just say I had a very personal experience with heat this morning, and that my office was without it for quite a while. And then also my daughter's elementary school, for those of you in Concord, Runlet Elementary was without heat today and sent all their kids home at 11 o'clock. So this is feeling very immediate. So I think part of my role here is to kind of tee up and I think kind of calibrate our conversation, as was already done by someone in the chat, as to, I think, the specific segments of biomass that we're talking about, which is heat. In my perspective, in coming to this topic is from my role at the Northern Forest Center. We're a 4-state organization that invests in rural community vitality in a lot of different ways, including working with the regional forest product sector, but also in sectors like outdoor recreation and on other topics related to rural community economic development. But I've been at this for nearly 20 years. The center is a 25-year-old organization, and this is our service region, and the region that when I talk about wood heat, I'm thinking about the 26 million acre northern forest region, historically really the birthplace of the modern pulp and paper industry. Still in a region very much dominated by its forests, both obviously ecologically, but also economically. And so for all of my remarks, I'm going to be talking about and drawing from the work that the center has been doing, along with many, many, many other partners, including Clean Energy New Hampshire, to grow understanding and where appropriate use of wood for heat. So I thought I would just talk about, why are we talking about wood heat? Sam teed us up a little bit. Heating with wood, of course, is nothing new. It's the original way of heating places, right? But I think we at the center came to start to work on this issue and appreciate it for a couple of different reasons, kind of observing some challenges regionally as we think about the Northern Forest region that beg these questions about what is our energy future when it comes to how we heat space in our region. And first is that we have this unique dependence in the Northeast on heating oil for space heating. This statistic is from the US Energy Information Administration that 85% of the residential heating oil sales in the US are in the Northeast. That's New England plus New York and Pennsylvania. Adds up to 2.9 billion gallons per year. And that means that we've got a pretty significant carbon footprint tied up in heating with oil, and also a very significant economic footprint. The estimate is that money spent on fuel oil, 80% of that leaves our region. So if you apply kind of current costs and that percentage, we're coming up on $8 billion a year that's flowing out of our regional economy for the purchase of fuel oil. And this is just in the residential sector. So that's a challenge, right? We've got this dependence on an imported heating fuel that has a significant carbon imprint and has fairly substantial negative economic ramifications for our region. Second, as we all know well, particularly today, we live in a cold region. We need the heat. And the region that I work in are really the more rural communities, which also tend to be less, economically prosperous places. We work in areas that for the most part have no access to pipeline natural gas, have older, inefficient housing stock. And again, in dealing with lower income areas, we're talking about residents who spend a larger amount of their income on heating. So for all of these reasons, at the Northern Forest Center about a decade ago, we were talking about heat as part of the regional economy, and also contrasting that with the landscape that we live and work in, which is a forested region. So this is kind of the opportunity side of the equation. The Northern Forest, again, that band of forest that I showed you across the roof of New England and New York, is the largest forested region east of the Mississippi, about 26 million acres of forest. It's currently growing wood at a ratio of two times higher than it's being harvested or removed from the woods. And because of larger macro changes in how our society uses wood, there is a lot of available feedstock that not too long ago had a home, particularly in pulp, in paper making. That no longer does. So that regional forest products economy has shifted fairly substantially over the last 10 or 15 years, which has fed into conversations about, okay, what are other economic ways that we can put wood resource to use? Another part of the opportunity equation here is our community economic development benefits. I talked about that huge outflow of wealth from the region for purchase of fossil fuels. If we can figure out how to spend that instead on local resources, those dollars stay in our regional economy and keep circulating. We want to think about how do we reduce heating cost volatility. I mean, what prices have done this winter have very real and sometimes severe impacts on people who just don't have the financial resources to handle those. And even for those of us who do, it's still quite a swing, obviously, to see our heating bills fluctuate so wildly from year to year. And then we also want to think about how our energy choices supporting local jobs and local economies. And then finally, climate, of course, is driving so many of our energy discussions and decisions right now. And there is a strong case that using wood pellets as a substitute for its fossil counterparts is substantially carbon better than those fossil counterparts. So all of these pieces together, I think, are how I would say this is why I would say this is a conversation worth having about what is the role of wood heat in our regional energy picture. And now I want to go a little bit deeper into each of those points just to share a little bit more context on those. And first is that notion that using more wood for heat can benefit forest stewardship. And here's how that works. In our region, the low-grade wood that is used for heat is a byproduct of forest management and wood products manufacturing. So many wood pellets, for example, are made from sawmill residuals. Sawmills are producing dust that can be compacted into pellets, or they're made from forest management residuals, trees, lumber that is not otherwise suitable for other purposes, or smaller diameter stuff that's coming out of the woods as part of harvest for larger pieces of timber. That's the material that has lost markets over the years, as you think about a society that uses a lot less paper than it once did, and a region that historically got a lot of economic benefit from those markets. There have been, I think now, a dozen paper mill or pulp mill closures in this region over the last decade. Markets for those materials help make forest stewardship economical. No one is out there harvesting just for the feedstock for wood pellets or wood chips. It would make no economic sense for a landowner or a logger to do that. But the existence of markets for lower grades of wood, which can be as much as 60% of the wood that comes out of any given harvest, make the overall fabric of forest stewardship economical. They make it work for landowners, for loggers, for truckers, and sawmills. And because of those massive changes in markets for wood, over recent years, this number moves around, but there's about 6 million tons of wood a year that not too long ago had a home. It was going to a paper mill or a pulp mill for the most part of it. That because of closures in those mills now, is still coming out of the forest, but does not have necessarily a market to go into. So the takeaway is an opportunity to greatly increase use of wood for heat, particularly as a substitute for fossil fuels, without placing new demands on the forest. To dig a little deeper into the climate case, a number of years ago, the Northern Forest Center actually sponsored some independent research from a group called the Spatial Informatics Group on the climate case. How does using specifically wood pellets for heat in this region compare against its fossil equivalents? And the results, I think, were quite favorable. As you can see here, again, we talk about wood heat as carbon better, 50% reductions right from the get-go against fuel oil, natural gas. And then over time, over the span of 50 years, those reductions become quite significant. This is a really complicated topic. I'm happy to dive into it in the Q&A, but I will leave it at that level for now. A lot of people ask questions about particulate emissions as well. And the modern appliances, like those sold by Froling Energy and their counterparts, meet all state and federal requirements and have particulate emissions comparable to fuel oil boilers. And lastly, I want to note that this is scalable, tested technology. We borrowed a lot of these ideas, our region did, from Upper Austria, which for decades has used this technology for heating. There are companies like Froling Energy that, as a consumer, you could call up today and have them, come to your house and talk to you about your options. So as we think about the need to act with urgency to reduce the climate impact of our heating choices, this technology should be in the mix. It's not something we're waiting for that needs to be developed for a couple more years. And then lastly, the economic case. This chart I just took this morning from the state of Maine. Their energy agency tracks the cost of a number of different heating fuels. And you can see here, given the current context, and I know Bill and others are going to speak to this, that heating with wood right now, we're not just talking about cost stability, we're talking about really substantial cost savings. And that has been true for many years, that the growth in wood heating fuel prices is kind of very slow, very modest, and very steady. in comparison to fossil heating fuel prices, which are doing this constantly. There is the case to be made for local wealth retention, the idea of keeping those nearly $8 billion spent or exported for fuel oil purchase circulating in our local economy instead of flowing out. That happens with wood and is very real in terms of those economic impacts. Just here in New Hampshire, there's 7,000 jobs tied directly to the forestry and forest products sector. So that is a co-benefit of these choices that we think is worth talking about as well. So Sam, that's what I prepared in terms of a top level overview, hopefully to tee up Jim and Bill, who I know are going to talk now, I think more specifically about particular ways that they're thinking about use of wood as a heating fuel and also the context of what natural gas markets are doing right now.
That's great. Thank you so much. And we will be handing it off to Jim Van Valkenburg next. I was expecting Mark Froling, but I'm thrilled to have Jim appear at the last minute and willing to take the slide deck and share it. Great. So Jim, I think we'll be talking about what's happening today, and then with Bill, we'll hear about what might be happening in the future.
Okay. Can you hear me then? That's
can.
good. That's good. Can you see my screen as well? The Froling Energy. Okay, that's good. All right, so we are a mechanical contractor that's been focusing on biomass boiler systems for the last 10 years, a little longer than that actually. But the key is that it's become these very high efficiency, very reliable boilers during those past 10 years. And we've just really been fortunate that that's when we got into the business and the evolution of the boilers. And they're European boilers. These are, we find that there's really no sources in the US for boilers that are of this right kind of credibility as far as we're concerned, is keeping everything reliable and efficient and very low emissions and so forth. Those are our priorities. We've been mainly focused on mechanical systems. So, I should say mechanical systems in commercial buildings. So that means schools, campuses. We've got a number of moderate sized commercial buildings, as well as some big industrial building campuses that we've done. In New Hampshire and Vermont are our main locations. I think we've got a few locations in Massachusetts that we've accomplished, but New Hampshire and Vermont have been very good to us. And New Hampshire has some very special aspects of things, including grants that are pretty generous, rebates that are very generous, as well as thermal RECs, which have been quite critical. So where solar has the RECs that they're selling to power companies who have to accommodate their rulings regarding the percentage of renewables that they're using in their output. They also have to do a type of REC that is for thermal wood-fired systems or other types of systems that are using renewables for thermal. And that's been a big boon to us because it helps to reduce the cost of fuel even further and make these systems that much more attractive. You can see a few different installations here in this picture, but we've actually shifted from starting out with wood pellets, which are great for small systems. But the more you get into larger systems, whether it be an elementary school or a large high school, that tends to want to have a lower cost fuel. And because of the quantity of fuel that it burns, it is able to afford a bigger investment in order to utilize the lower cost fuels. And one of the things to say is that wood pellets are an extremely efficient and easy to use fuel. It's very low in moisture content. It's down to 7 to 8%. And it's also this pellet that's very compact. And it also flows very easily, whether it be, if you got a bag of pellets and chopped off the bottom corner of it, it would all just fall out onto the floor. It's just that easy to move around. But you can also move it around using pneumatics, as well as auger systems and very lightweight augers, such as flexible augers that can move it around very easily. But when you get into the things that are the other fuels, which are chips, different types of chips, we have dried wood chips that we manufacture over in Keene. And there's also the greenwood chips that heat many high schools in the region. And those are bigger, chunkier, wetter. The dried wood chips are screened to small size. I like to say about the size of a matchbook, and that as the biggest. And then they're dried down to 25% moisture, so they can actually be blown. So there's this sort of these 3 levels of fuel, depending on how much fuel you're using. That's probably the best choice for one of those fuels would be best for you. In the case that we're looking at here, there's a big silo. You can see it actually being installed. This is John Stark High School. This is Campton Elementary School here. And you can see these big silos that holds the equivalent of about 4,000 gallons of oil in that one tank. And it's blown in from a blower truck, the fuel is, and then it just gets augered directly into one of these boilers. And this happens to be the Campton Elementary School boiler here. It's a Schmid Swiss boiler. So that's just a real simple idea. This is what a boiler room might look like. And you can also see that, we're also consulting an awful lot with this scale project. You're not just talking to a homeowner and saying, we'll change out your boiler. There's very often a bigger project involved, and we're talking to engineers and architects and building owners with a longer term planning that goes on for these kinds of things. Sometimes a separate building is required, such as in this picture here with the Campton Elementary School, where the boiler room needed to be built outside of the school. There wasn't enough room inside the school itself. And that contains this boiler, the backup boiler, as well as a buffer tank, and then the silo right next to it. In the case of John Stark, there was room in the boiler room. It was renovated completely. So a brand new backup boiler, a gas boiler was installed, as well as a big Schmid boiler, just like this, as a matter of fact. So that was all done interior. So there's different approaches, and you can see this is like what might happen if you had interior silos. This, in fact, looks very similar to the UNH project, which I'll explain to you in a little bit. Again, we manufacture these dry wood chips over in Keene at a new facility that we've built here. The chips look kind of like this. There's a K-cup that everybody kind of knows what the size of that is. So you can see the chips are kind of smallish and refined, and again, dried down to that 25%. And this is how we blow the chips from this big semi truck that looks like a live floor truck, and it is, but it's been modified to actually have a blower that blows it up these pipes, this big J pipe that goes up and down into the top there. It blows up in there and then fills these silos. So we haul about 25 tons of these chips at a time. And each ton is worth about 93 gallons of oil as an alternative. And we're offsetting a tremendous number of gallons of oil. And that really makes us very happy just with our fuel. And then the wood pellet systems we've installed are offsetting an awful lot of fuel as well. So we're I think it's just about 1 million gallons of oil a year are being offset by all our customers. And that's pretty significant. Here's our plant over in Keene as well. You can see that we've got the incoming chips here, go into the plant, and it's fully automated so that nobody really has to touch these things. It all gets screened and dried and then comes out the other side on a conveyor and drops into place here. And we load up our trucks from that point. I'm going to show you a different screen. I'm going to stop sharing here, and I've got a different screen I'm going to share. And that would be right here. And I just want to show you do I have the right one up here? No, that's not the right one. I'm sorry. Let's try it one more time. I have, boy, oh boy, where is it supposed to be? It's hiding here somewhere. I think maybe I have to look someplace else. Hold on one second here.
Shall we tell some jokes?
Tell some jokes. Please tell some jokes. Here we go. Okay. I think I'll be able to share this now. So we're going to do that, and we're going to go to this, and then we're going to share. All right, there we go. Okay, so this is the UNH project that we put in, just to give you a sense of this. One of our smaller blower truck that fills through this J pipe, and that has an interior silo indoors. So this is just an interesting area. We're doing the Northwest heating plant. We built this It actually is the Thompson School, if you know the UNH campus. There's about 10 greenhouses that also we're heating with that. So that's with the dry chips. It's a retrofit in a major way. This was actually a brand new boiler room. The area had no specific boiler room. It was the end of a heat pipe that was coming from the center of the campus. So they cut off that heat pipe, and this is now the new source of heat for the Thompson School area there, as well as those 10 greenhouses. And it's got a gas boiler as well as a biomass boiler. Let me show you. This is Plymouth Regional High School with a Viessmann boiler inside there, as well as this silo. And you can see that it's 2 million BTUs, 2.45 million BTUs. John Stark High School, again, you've got this where the silo is here. It feeds into the building, gets into the boiler. The way that works. I briefly want to just show you, give you some ideas of what's possible here. This is a steam boiler system. This is the first one that we had done as steam. Everything else has been hot water. So you know that's possible. It's just a larger scale. So you have a steam system that was at this high school. Is called Mill River Regional High School in Colchester, Vermont. And they had steam distribution. It's always good to try to change that out if you can, but it's a very expensive proposition to change out your distribution system. So, even though you can be more efficient with hot water, it would have been a tremendous amount of money. Let's say just $100,000 minimum to change out, just even a smallish school to get everything into hot water. So in this case, we stuck with the steam, put in a brand new steam oil boiler, as well as this boiler does about 95% of the heating of the school, with this just the oil boiler just acting as a peaking and backup. And that's a great compromise. It's wonderful to think about going 100% biomass, but in the long run, it just makes sense to have this simpler boiler as a simple peaking and backup. So when it's really cold, like right now, you're getting those -10s, -20s, you're able to run the chip boiler full blast, but then we can go up to those special once in a while loads that happen during real cold periods like this. We also set up a central heating system for a campus in Wilton at the High Mowing School that did not have central boilers. It had a boiler, there was, I think, 9 different boiler rooms on campus. And every one of those boilers, because this school has just been, eking out their existence over the years, so many years had passed, and it was time to change out just about every boiler on campus. And so it started to make sense to look at a central approach. So that's what we did. We put in a central boiler house, this boiler house right here, and then ran pipes, you can see, in these different directions from that central boiler house to connect to all the main buildings and eliminate all those separate boilers. And we put in these 2 LP boilers to act as, again, peaking and backup, because you've got a school here. You want to make sure that you've got heat at all times. These were able to carry the whole load if necessary. But in this case, the boilers, these 2 boilers worth 1 million BTUs, were able to heat the whole campus in most cases. Big buffer tank, big piping system, very complex. This is not the sort of thing you can just enter into and say, we'll just come over there and put this in. There's engineering, lots of engineering involved. And we deal with a lot of mechanical engineers to set these sorts of things up. So that's what we do, and it's a real business. We're working all the time on new projects, and it's been a very very gratifying, I think, to be able to offset as much oil as we do, and to have customers that are being taken care of with a regular service department and so forth. It's not rocket science. It's basically a very traditional kind of business that we're in to support our customers, to make sure that they're this weird technology that, the average plumber is going to go, I have no idea what this is all about, where we can go in and we've gotten that knowledge, and we maintain these systems and make it normal for New Hampshire. And it is very normal for New Hampshire as far as we're concerned.
Great. Thank you, Jim. And folks, remember, we're going to have a chance for questions coming up very shortly. So start to queue up your questions, whatever they may be about. and we will get to them as soon as Bill has his moment in the sun. So Bill, tell us. So Jim, actually, can you stop sharing your screen?
Okay, there we are.
There you go. So Bill, why don't you take the helm here?
Thank you. Let me. Look for this. How's that, Sam? Are you seeing my screen?
Looks great.
All right, great. Thank you. Good afternoon, everybody. And thank you for the invite, Sam. Appreciate it. And Joe and Jim, great presentations. So my name is Bill Clark. I am the Senior Director of Business Development for Liberty Utilities. I cover all modalities that we have: gas, electric, water, wastewater, acquisitions. You may know us as Energy North and Granite State Electric. So we are the largest gas utility in New Hampshire and a relatively smaller electric utility, about 95,000 gas customers and about 45 to 50,000 electric customers in New Hampshire. Going to talk a little bit today about the regional natural gas supply, how it gets here, what the pricing looks like going forward, and what's driving those price increases, especially during winter. Also going to discuss some local renewable natural gas, or RNG, and hydrogen opportunities. And then specifically to tie into Joe and Jim's presentation, potential thermal renewable energy in natural gas form from regional forestry supplies. So as I mentioned, the water and wastewater side for Liberty, we have a little over 293,000 customers around the US, 267,000 electric utility customers around the US, and 369,000 natural gas customers. Those numbers do not include, we recently announced the acquisition of Kentucky Power, electric utility in Kentucky, recently closed on Bermuda Electric, which everybody in the company has their hand up this winter to volunteer and go work at Bermuda Electric. So that's becoming very popular. And then we also acquired a water and wastewater utility, pretty large scale, a little over 200,000 customers in Chile, South America. So very, very growing aspirational company. So this slide here, I stole the slide from the Maritimes and Northeast pipeline. It kind of paints the picture of how gas arrives into what we call the Algonquin City Gate, Drake being the major trading hub. So if you can follow my cursor on that screen, this burnt orangey pipeline, that's the Maritimes and Northeast pipeline, which originates in Canada, pulls in natural gas from offshore wells near Sable Island. As you come down, there's an LNG import facility right around here called Canaport. Repsol is the current owner of that facility. That'll be important in a couple of slides when we talk about natural gas pricing. And then the PNGTS, which is the Portland Natural Gas Transmission System, that brings gas in from Canada, cutting down the Vermont and New Hampshire border, cutting over through Berlin and Groveton, back into Maine. And then these two pipelines form what they call the joint facilities. So these two pipes merge into a central pipe that feeds down into Drake. And then coming in from the south, there is the Enbridge pipeline, and then the Kinder Morgan pipeline, which also feed the Boston Algonquin City Gate market. And I think you see in the news quite a bit if you're following liquefied natural gas deliveries. In Boston, it's the District Gas facility, which is in Everett, Mass. I don't know if anybody has been driving over the Tobin Bridge as those LNG tankers are coming in, but it's a pretty big event with state troopers and police helicopters escorting that ship in. So these are the four major pipelines and the two LNG facilities that we receive our natural gas for most of New England. And the natural gas pipelines, especially these coming in from the west and southwest, are at or nearing capacity. And to date, there's really no planned new pipelines coming into the market, which means As we expand natural gas use for home heating and for electric generation, the incremental demand is being made up from liquefied natural gas into the Repsol and into the district gas facilities for winter peaking. What's happening is the LNG is really driven by a global supply market. So Asia and Europe are heavily dependent on liquefied natural gas. So New England is competing with the world market for those cargoes to be docked into the local distribution systems in New England, in the worldwide markets as well. So that's what's been putting the upward pressure on natural gas prices. This slide is a chart, two charts. But again, the Boston Citygate pricing. This was the January for 2022. So this was this month. If you look back when these futures were being priced back in April of 2021, they were at the 750 and MMBTU price range. And as we got closer and closer to winter, with demand coming back, hopefully coming out of the COVID lockdowns and productivity increasing in winter demand needs, they were creeping up to the $25 range per MMBTU. The slide to the right is last winter versus this winter. So last winter's actual pricing versus this winter's forecasted pricing. And last winter was a mild winter, some still COVID lockdown. So our Liberties and other gas utilities did not send out what we call a design year or even a high year. So the pricing was pretty consistent, never really topped $5 for winter pricing per MMBTU. This year, we're in the $6 range up to over $20 for the forecast for this winter. And again, the majority of that is due to pipeline constraints, purchasing available gas in competition at the Citygate, and also landed cargo of LNG. So what Liberty does, if you look at this pricing, is you'll notice that our pricing is much lower than those winter forecasts. So Liberty has a great percentage, and all utilities, Unitil in New Hampshire as well, they contract on long haul capacity contracts. So we buy a great percentage of our supply under long-term capacity all the way down to the Gulf of Mexico and Marcellus, and we pay fixed capacity charges to move that inexpensive gas up to New England. So the capacity is pretty much at the point where it's limited on what we can expand to that capacity to. The other situation that arises when you're trying to plan for this is, do you really want to sign up for 365 days of capacity for maybe 20 to 30 peak days in the winter? So do you want to sign up for your peak day capacity 100% of the time, or do you want to fill in those needs with spot pricing LNG, which is historically utilities have done in the past in New England? Those cargoes are getting much more expensive for LNG, and the long-term forecasts of that are pretty much saying the Algonquin Citygate pricing, because of the high demand for incremental capacity being reliant on LNG, that spot prices for AGT going forward will closely correlate to the worldwide LNG pricing, which is getting very expensive. So what do we do as a utility with the supply issue in mind, and also with an eye towards decarbonization and net zero? How does the gas utility look in the future? So I want to talk a little bit about renewable natural gas and hydrogen. So renewable natural gas is pipeline quality gas. It can be injected into an interstate pipeline or a local distribution network, and it's been refined to the point where it's interchangeable molecularly. So there's no end use equipment that is required. And it is derived from organic waste streams, the circular economy. So in this picture here, you'll see anaerobic digestion, thermal gasification, and power to gas. So the digestion part is, think of a landfill that is venting or flaring their gas. That flared gas is captured, upfitted to take out all the impurities to make it pipeline quality specification, and then it can be injected into the pipeline. You can also develop anaerobic digestion through a biogas treatment facility at a dairy farm, a wastewater treatment plant, a food waste separated organic digester that could either be standalone or incorporate sludge biosolids from wastewater treatment plants to increase the capacity. Those fuels are either very low carbon, carbon neutral, or in many cases, especially with the separated organic food waste, wastewater treatment, and dairy, are actually carbon negative. They remove more greenhouse gas emissions than otherwise would be put into the atmosphere if nothing was done. Thermal gasification is the tie-in to the two previous presentations, where you can use low-grade wood that would otherwise be unutilized or underutilized to construct renewable natural gas that goes into the pipeline. And the third being power to gas. And so this is taking solar and wind resources and running the electrons through an electrolyzer, which is basically separating hydrogen and water molecules, creating pure hydrogen. And then what you would do to make it chemically the same as regular natural gas, you would take a form of carbon capture from another facility to mix with the hydrogen, and now you've created synthetic natural gas, which could really help on supply issues, and if dispatched in areas of need, and when I say need, I mean I'm thinking more of pressurization and physical operating capacities of the natural gas network, could be really beneficial. And so also an analysis of hydrogen production equipment. So hydrogen is really being looked at as a Swiss Army knife. You could use 100% pure hydrogen as a fuel cell vehicle, forklifts. You could use it for power generation. You could blend it into the natural gas pipeline network. And in Europe, they're much more advanced than we are currently, although the Biden administration has announced their Earthshot through the Department of Energy, where they want to get clean hydrogen produced around $1 a kilogram by 2030, and $1 a kilogram translates to about $7.70 to $8 in MMBTU. And as you saw on some of those previous charts, that's actually carbon neutral gas that is at or below winter pricing in New England right now. I threw a couple examples of the technologies to produce the hydrogen. Steam methane reformation, you can use natural gas or RNG, utilize carbon capture with that. Electrolysis, as I mentioned, is through electricity, and that could be either dedicated renewable solar and wind or baseload grid power. And the last is through biomass or forestry products through gasification or pyrolysis. Also through some manufacturers that are kind of leading the technology revolution to produce the hydrogen. And then on this slide here is thermal renewable energy from the regional forestry. So we contracted late last year with Innovative Natural Resource Solutions to evaluate the forestry feedstock for RNG production facilities. We looked at both feedstocks that are RFS and non-RFS eligible. RFS stands for the Renewable Fuel Standards. It's a credit trading mechanism through the EPA. And also many states have their own low carbon fuel standard credit trading mechanism. So RNG and hydrogen, you can receive federal and or state credits available. And depending on the facility's carbon intensity score, you are graded on what classification or how many LCFS credits you produce. And then depending on your feedstocks on the RFS, you would be in different, what they call renewable identification number categories, R5, D3 and D5 being the most common. So what we looked at with Innovative Natural Resource Solutions is a substantial plant. And so what I mean by substantial is about 3 BCF of annual production of renewable natural gas through forestry. And to kind of put that into context, if you add up the annual send out of Liberty and Unitil in New Hampshire, that 3 BCF facility would be about 15% of the annual supply for all of the New Hampshire gas utilities. And each one of those locations to produce 3 BCF would require about 350,000 tons of waste. I think it might have been Joe who mentioned, I think on his slide, that there was up to 6 million tons of available feedstock. And so to qualify for the credit programs, you'll see that the roundwood does not qualify. That's more of a high use wood. So what we concentrated on was more of the slash mortality, which is RFS eligible. And as you can see in the outcome, the 4 locations that we were looking at as far as being the hub or a potential location for production facility, any one of those locations would qualify for feedstock availability to produce RNG in substantial quantities for New Hampshire customers. And with that, I will close it out there and stay safe, everybody, and I'll stop sharing.
Great. So let's take some time to answer some questions. I'm noticing that there are some questions that were put into the Q&A box, and our panelists have very ably stepped in and are answering those questions in the Q&A box itself. I'm curious though, do either of you want to take any of those questions live? I'll just put it to you. If there's a question that you really like and you think that all of the audience would benefit from hearing the answer to, I'd say feel free to hop in and answer it live. But I'd also say if any of the participants want to ask your question with your actual voice, like I said at the beginning, feel free to hit the raise hand button and I can unmute you as a participant. So while we're waiting for folks to think about that, so Jim or Joe, are there any of those questions that you answered that you'd like to again speak out loud?
Sure. The one regarding the backup systems, I thought was an interesting one, and I spent some time answering that. But
and the question, just to repeat it for those who didn't read it, why do you need to have a backup system for the wood pellet or chip furnaces? If one buys a gas or oil furnace, no one's suggesting you need a backup for that. It sounds like you don't have confidence to do the job. So do you have confidence to do the job, Jim?
We have confidence to do the job. In a residential situation, some 90% of the people are probably have a boiler that's failed. So they just want to replace it and they put in just a single wood pellet boiler, and that would be that. But, in schools and, town halls or all different types of businesses, they want to have redundancy. And in fact, when I go into any facility to take a look, there's usually, 2, 3, 4 boilers in a row. And generally, 1 or 2 of them would be able to do the job, especially if there's just 2 boilers. One is able to do that job entirely. And they have the other one there, they'll trade back and forth, but one is a backup. It truly is a backup. It's redundancy, just good common sense, good engineering. So that's one of the reasons why we do the 2 boilers. The other one is I can reduce the size of my biomass boiler down to about 70% of peak load of a building. Anytime a building is designed, the engineers come up with what they call the peak load, which you have to meet with your boiler system. So let's just say it's 1 million BTUs is the load. I need to be able to have a boiler capacity that'll do that, but 70% is 700,000 BTUs. And that's what my pellet boiler or my wood chip boiler would want to be. And then we'd have an oil or a gas boiler that covers 100% of that. So now the 2 work together. It's basically the biomass boiler is the steady load, the steady Eddie, just running all the time. Once in a while, you've got to stop it and clean it. So it's good to have a backup in that case. But it's also, again, periods like this right now, you're above that you're really approaching your 100% peak load situation. And that's where an oil boiler is just going to come on and just going to pitch in when it's needed. We're going to still run the chip boiler, but this will come in and just give us that extra boost that we need when it's -10, -20 outside.
And I think what this speaks to is that really a lot of these systems that Froling is installing are of a very different scale than your typical residential system is looking at, which gets to another question that was in the chat. Rick DeMark asked, what is the scale that you are seeing the greatest demand for these thermal systems? So is it really mostly these big institutional installations that are getting installed? And Joe, you could chime in on that as well, because I know you all have worked on residential high efficiency wood heating appliances.
Yeah, good. I'll just say that we do mainly, it's the commercial side. That's where, the scale, the dry chips, basically people are buying the dry chips. It's kind of like buying oil at about 90 cents a gallon on a steady basis. So people, you can't beat that. And, wood pellets are more costly than that. They're more in the range of, say, $1.60 a gallon. And these are with thermal RECs involved in New Hampshire. If you're just a residence, it's closer to $2.10 or something like that a gallon oil. And we always seem to compare against oil, so I apologize for that. But that's it just seems like it's the scale that causes someone to be concerned enough to make the investment. And it's more altruistic on the side of a homeowner that they say, I just don't want to burn oil anymore. I just want to, do something else. Go ahead, Joe. What do you find?
Yeah, no, I mean, I would agree with that, Jim. I think until very recently, and I don't know if you guys are seeing this, but we're certainly seeing the residential interest spike this winter with the cost of natural gas and oil, because you don't have to be motivated simply by values and altruism. There again there's a cost savings, and we can talk about kind of the payback period for a homeowner, because these automated systems cost more upfront than a fossil fuel equivalent. But if you're saving money over time, you can talk about, okay, that payback period. And that's what I'm observing has returned in the last 2 months. I would agree that for the last few years with cheap oil, most of the interest has been at the larger scale installations.
So we have a question from Scott Nichols in the Q&A, who was going to be a panelist, but Scott, I should promote you to a panelist and have you chime in. Scott works for owns TARM Biomass, but he wants to know how much power is required to create 1 million BTU, or excuse me, 1 MMBTU. Is that 1 million BTU?
Yes.
Yeah, that's so. Just make sure I have my units right. 1 million BTU of hydrogen via electrolysis. So maybe Bill, can you not only take that, but maybe also just sort of speak to try to give people a sense of scale here when we're talking about hydrogen production. How much do we think in order to get through these sort of seasonal peaks? And what does that translate to in terms of, the types of power plants that folks might see, or solar arrays that folks might see out in the world?
Yeah, so good question. And I'll have to double check with my technical advisor on that, but I can give you kind of a breakdown of like a 1 megawatt solar array with an electrolyzer would produce anywhere from 10 to 20,000 MMBTUs a year, depending on the uptime of the facility, the capacity factor of how long it's running. So again, the biggest input on the cost of the hydrogen is the utilization factor, right? So if you have a big, large sunk cost of an electrolyzer, but you're only running it 7 hours a day because that's when the sun is shining, you're not really utilizing the full capacity of that piece of equipment. So really what we're trying to do is base load that. And I can give you kind of an example. So we had a study that was commissioned in New York for our gas utility in New York. And we're in 3 small counties in upstate New York: St. Lawrence County, Franklin County, and Governors on there. And so much smaller than Energy North. So we have about a third of the annual send out for natural gas in New York as we do in New Hampshire on an annual basis. The studies show, because there's a glut of renewable generation in those 3 counties, where pricing already goes negative and these renewable resources are curtailed from the electric grid, that we could convert 100% of our customers and 100% of the natural gas to 100% hydrogen, utilizing only 40% of the existing renewable generation that's online in those counties. So it's really, location based, but there are some great opportunities and some that you're going to need to wait for the grid to be built out, like in ISO, with much more renewables for that scenario to play out.
This is a question in the chat that I think is a really good one, from Kathleen Kelly. So the 4 hydrogen/biomass plants that you referenced in your presentation, Bill, would that drive the cost of these low-grade wood markets? Would that increase the cost that folks are paying for chips And so I think this is a good one for Bill and Joe to sort of tag team, because Joe, I think you probably have the more historical perspective on where the market is for low grade wood right now compared to when, the pulp and paper really was kicking. And so what are we talking about when we talk about the amount of demand that building these types of
So
plants?
I guess I'll jump in and turn it over to Joe, the expert on this. But part of our outcome of the study is to we were looking at, would we affect the market in a negative way, right? So that's kind of why we picked those 4 locations and the scale that we picked, which we thought was significant for our requirements or New Hampshire's natural gas requirements. The report's 88 pages long, so I'd have to kind of get into where that pricing scenario is, and I'm sure Joe has thoughts and comments on that.
I mean, I think it's a good and important question to think about. And I think the sense is that, again, compared to where we were 10 or 15 years ago in this region, there are millions of tons of this lower grade wood material, that don't have a home. So again, 15 years ago, they were going to something.
Yeah.
And they're not. So I think that has created this sense of like, there's room to move here in terms of thinking about new innovative uses for that material, like, the wood fuels we already know, but also the ones Bill's talking about. And also like other really cool green things. There's a business that just opened in Madison, Maine, that is going to start making insulation, for your home from wood. So there's a lot of focus going into new markets, and also a sense that we would have a ways to go before we started that need to have those conversations about impact on the forest. A single pulp mill, for example, might take in a couple million tons of wood a year. A large wood pellet mill is 100,000 tons or a little bit more, just to kind of give you a sense of the scales we're talking about.
And for natural gas, RNG was about 315 to 350,000 tons for a really good size. And we picked those 4 locations really. We talked to some developers out there, and a large capital cost for them is constructing the facility. And they mentioned that if you could repurpose an existing biomass or wood pulp facility, it would drastically reduce the capital cost required. And the other part is access to a natural gas pipeline where you can move the gas to market.
Good. I was just going to say that we processed, I think we're going to be about 7,000 to 8,000 tons of dry chips, which means we took in maybe 20,000 tons of green wood chips, bull wood, that is. We can explain that a little more, but we find that in the last couple of years, with the biomass plants basically being shut down and the demand really low, I mean, there's all kinds of people that are looking to get rid of, whether it be urban tree waste or whether it be, thinnings from a logging operation. There's a lot of people looking to get rid of that. It's just going nowhere. A lot of it's just laying in the woods now because they go in and they pick out the good stuff and they just leave the rest. That's kind of sad for our forest in a lot of ways. That's kind of another issue, but we certainly know there's a lot of availability out there, and it's definitely, the demand has lowered over the last few years. So there's companies going out of business that are no longer doing the logging as a result of this. So, and that was sustainable harvesting, generally we'll say.
And it's important to remember that when slash is left in the woods, some of the carbon embodied in those tops and branches does become soil and does get sequestered, but a lot of it just goes back up into the atmosphere. And so it's not necessarily a climate win to not use those materials. Well, folks, we're at 1 o'clock, and I'm seeing the attendees. Some attendees are having to drop off for other meetings. So just a big thanks to Joe, to Bill, and to Jim. Thank you for taking the time to be here. And just as a reminder, this will be available. We have recorded this presentation, so it'll be available on the website. And please tune in for the next one, and tell your friends that they should tune in as well. So thanks so much, everybody.
Thanks, Sam. Enjoyed it.
Thanks, Sam.
Thank you. Thank you.
Thanks,
very
Bill.
much.
Thanks, Jim.
Thanks for including me.
Good job on the fly. Take
Thank
care,
you.
everyone.